Hi there, I'm Yorick, this is Brad, and we should have been doing this with Kurt, but he's stuck in the transit, so it will be just the two of us today. We'll give the short presentation of FreeCAD. Is it okay if I do the introduction? Okay, then I will just give a short introduction of the project for who doesn't know it, and then we'll show a little bit of example of what we do around FreeCAD and other stuff. So for who doesn't know FreeCAD yet, it's a 3D modeling application. Basically, we used to say it's 3D application made to build objects that will be built in the real world, to make the difference with like applications that are used to make animation or movies or stuff like that, which is not the focus of FreeCAD, because it has all those precision tools to make really precise things, such as this thing. It's really made to make such objects. From people use it to make small electronic components up to buildings. I'm an architect myself. I use it to make to draw buildings. Brad is in CNC. He uses more for CNC. And there's a wide range of uses around FreeCAD. And basically, it's most of FreeCAD users use it to do 3D printing. That's it, I believe, its main use today. It began in 2002 with 2 developers, and now there are like, I would say, 20 or 30 people committing every week or so. So it's really growing, and it's going quite well, actually. And an interesting part of it, that's what we want to showcase today, is that we have, it's not really a project with, I would say more than half of the developers are not from the programming background. I myself, I'm an architect. Brad is also not a formal programmer. And most of the developers didn't learn programming formally. They just came to the project, and since it's quite easy to grasp some Python from it, because it's you have that Python console all the time. Everything you do in FreeCAD reflects in the Python console, which is around here. Every time you push a button, you get actually a Python command printed and executed there. So it's quite didactic. You use FreeCAD and you learn some Python on the way. And most of the developers entered the projects that way, actually. Many of them. There are some professional programmers as well. So this is what I'm going to talk about. You want to start? Or no, okay. So I will show you a little bit of what I do with FreeCAD. I'm an architect by trade. That's my day job. And actually, we have this architecture studio, myself, more 4 or 5 people, which is almost totally open source. It has no physical location. All the projects we do are mostly open source. We just keep the private data of the clients encrypted. So all the project goes on a GitHub repo, and just the private data is encrypted, so public cannot read it. And this is a kind of example of what we do. We use a lot of FreeCAD in it, but this is a proprietary platform from Autodesk or Revit, just to show you that whatever you do in FreeCAD is quite now reliably interchangeable with proprietary applications. Some of our team use it because they want it. But the idea is not to be a zealot and say we only use open source. Some clients want the proprietary formats as an output, so you have to deliver the proprietary format. But the idea is to say anything works. Like you can plug various components in the tool chain, and it should work seamlessly. And that's what we're trying to achieve. Some are working with FreeCAD, some are working with this, and it should just go around. That's our office. It's on GitHub, and all the projects are there. That's the latest one we've done. We're doing. and it's fully developed the open source way. So these are the project files, and it looks these are where our team is located. This is how we use Riot for discussion, and all the technical discussions happen online as well. And this looks like common for open source developers. That's how an open source project works. But I can tell you that for architecture, it's totally uncommon. People don't work that way, and we're really trying to bring the open source way to an architecture office, and FreeCAD is really at the center of it. Everything we learn from developing FreeCAD reflects in that office. That's another project we've been doing last year. That's a WikiHouse based building we've built in Brazil, and it's basically to showcase how things mix around FreeCAD. Basically it's a house built by people, even people without knowledge of building, and it's all made of pieces of wood that are cut by a CNC machine, and that are assembled. There are numbers printed on the pieces, and you have a manual that shows you piece 4 goes into piece 2, and you mount the thing like that without any nail, without any glue, without any other thing, just the strength of the junctions. And it's all open source. We took it from its original project, we modified it, and the result is also open source. That's it for my part.
So I'm going to talk primarily about the path workbench, which is the CAM functionality. And this is a really great example of what Yorick was talking about with kind of a cross-discipline participation on the project. This started out in 2014, and I came at the CNC CAM thing as a hobbyist, and was just one of a lot of people that were frustrated that there was no good CAM application in the open source, and particularly the Linux world. And so what we did was, we were already users of FreeCAD, but wanted the CAM part. And so we partnered with Yorick first, and got the core design for the C++ part in FreeCAD that handles storage of the actual toolpath data and the visualization, but none of the user-facing functionality, none of the job control and tool setup and things like that. And then that part was all written by me in part, and then more of the community members coming on little by little. And at first it was really, really bad. And I whined to Yorick about not knowing what I was doing. And he said, don't worry about it. Just do it. And somebody will come along and fix it later. And honestly, that's what happened is better programmers than me came on, refactored code, and the thing started to gather users and get some momentum behind it. So this is the typical workflow. We're designing like a bench, and you're starting out with a model, and then within FreeCAD you have to take the components and reorient them for cutting on a machine. So you have to lay them out into a 2D arrangement, like in the upper right corner, and then generate the tool path that's going to move a cutter around those shapes, lifting it to clear the spaces in between. And the bottom left shows that operating on an actual CNC router, and then the final product down below. So that's a typical 2D or 2.5D process. Where we're now starting to move into is a little bit more sophisticated tool paths, like this is adaptive clearing. So when you're trying to mill away metal from a shape, you need to keep the cutter at the same level of engagement with the material the entire time to avoid it speeding up and slowing down and breaking and so forth. And so you're seeing a much more sophisticated tool path in the upper left. That was to mill an aluminum block that's used as a brand on a wooden cover. This is another area where we're moving into. This is a fourth axis, where you've got a shape that needs to be milled on multiple sides, and so we're rotating it I'm cutting a piece of foam in the upper right, and then so the toolpath has to recalculate for each position as we rotate the part around. This is where we're now calculating surfaces and doing more smoothing passes, or in the case of the one on the left, where we want to do a regular operation, but we want to do it on multiple faces of a part. So you need to reorient the part on a 4th axis or a 5th axis. Well, the toolpaths that you're seeing here, the work that was done, is by one of the newer developers that has joined, and he's a Spanish teacher in Oklahoma, and he does this as a hobby. And it's surprising how much he's been able to move it forward, you know, with a little bit of coaching and then just, you know, guts and determination. So this is one other area. One of our other developers, who's a real programmer, a serious programmer, has wanted to go one step farther and integrate direct control of the CNC machine within FreeCAD. So instead of the traditional, you set up a toolpath and then you post-process it and you get a G-code file, and then you take that over to the CNC machine and load the G-code file and run it. What he can do with this is, from FreeCAD, he can connect directly to a CNC machine that's running Machine Kit and select the path job that he wants to run. And the numbers that you're seeing in the top left of the 3D window, that's the DRO, the position coming directly from the machine. So the indicator in the 3D window on the kind of on the left side is the cutter position within that window, and when he runs the job, you'll actually see the cutter move and follow the path that's generated. So yeah, this is, you know, now a developer who came in initially for one little feature has started to, you know, make bigger and bigger contributions, and now his contributions are getting outside of the path CAM workbench and getting into other aspects of FreeCAD as well. And that's really a very typical process. The thing about CAM is that the community is running a wide variety of machines, and each of those machines needs unique G-code generated for it. So one of the first places that we're seeing developers come into the project is they're writing a custom post processor for the machine that they've got, or for the machine that they sell if it's a company. And that's a really easy contribution to make, but then invariably it's like, it does everything except that one thing that we need. And then it's a feature. And then eventually they start working on the core stuff. So it's been a lot of fun, and it continues to accelerate, and I think we got some fun stuff coming up in the future. So that's what I've got. We'll do Q&A. So these are a few of the post processors that we have right now from Linux CNC, Smoothie, Centroid, Dynapath. So quite a few of the most common machines that you're going to see in, especially in hacker spaces or small companies, we can generate G-code for right now. Yeah.
I don't know if it's a part of CAM. It seems to me unfolding. I mean, you model something, a shape, and you want to make it out of sheet metal or foam board or something. And is it possible, or is there anyone working on it to make a module that unfolds it and tells you how to cut it out?
There is an add-on workbench that can be installed through the add-on manager that's called sheet metal. And you can both design for sheet metal and take parts that were designed that way and unfold them into a 2D representation. So yes, it is there. I won't say it works for every model, but it's there. Yeah. I'm sorry?
Which libraries are you using for toolpath generation?
He asked what libraries we're using for toolpath generation. Right now, most of the 2D and 2.5D operations use a module within FreeCAD called Path Area. That's basically an implementation of the Clipper lib by Angus Johnson. It's been around forever. We also use OpenCamLib and OpenVeroni a little bit that are for doing The Veroni thing is not merged right now. That's in a branch on my repo, but we can do like centerline engraving of fonts. And the Open CamLib we use for the like the surfacing that you saw in there.
Yes, in particular to architecture and building information modeling. So what are the main arguments for me to use for my colleagues and my clients to drop the other thing and use FreeCAD?
Can you repeat the question?
Yeah. So he asking what are the best argument to switch to FreeCAD as a BIM platform. I would say basically the freedom that all other platforms, commercial platform, would try to lock you in a universe where you just use their platform and their file formats, and you will have to use their other solutions of their family together. And by using free software, basically you free yourself from that. I would say technically you basically can do in FreeCAD the same as you can do with commercial platform. Almost like every free software, you have to search a little bit by yourself for some solutions that are not so obvious, but basically technically it's there, you can do it. And I would say the best argument is that it's the freedom and the hackability, because FreeCAD is totally hackable. You do it, you do what you want with it, you reprogram it, you write macro, you can, it might be just 5 lines of code, so it doesn't need to be like entering the programming word, and you already make it do what you want. And it's extremely easy on FreeCAD, and it's really hard on other platforms, even with tools like Dynamo, etc., which are not easy. And so it's basically another world, another way to see things. Yes?
You said that you use Git for your project files, and do you have any good recommendation about the workflow you use, and if there are any plans to include it inside FreeCAD, like you have a way to have diffs between the files and stuff like that? Because I think that this is the biggest issue I think right now, because we use it a lot this way, and this is the biggest issue because of the binary files and stuff like that.
Mm-hmm. Yeah, so the question is, what about using Git with FreeCAD and with architectural workflow, and are there any plans to integrate Git better with FreeCAD? I say, yes, we use Git a lot, and it works. It has those limitations that you say. We have already a couple of tools in FreeCAD to work with Git directly, but let's say the advantage of it is basically keeping you free to manage it outside of FreeCAD, and it's actually a good thing. That it's not tied in FreeCAD, and you just manage your files the way you want, without the way FreeCAD developers would think you would need to. So yeah, you have a plugin in the add-ons where you can have a Git panel in FreeCAD and you can commit from there. But even me, I wrote it and I don't use it because it's more convenient to do your file management yourself outside of it. And on the IFC side, IFC is a file format specifically for construction models. Yes, we have already begun to have a couple of diff tools and tools that allow you to see a difference between one version and another version of the file. There is one in the BIM Workbench in FreeCAD. There is one being developed for Blender as well. Blender begin to have a good IFC interface, and so you begin to have in the whole open source world several things that are bettering in that regard. And so yeah, I believe pretty soon we'll be able to use IFC files the right way, let's say the open source way with all the features. Yeah.
So you haven't had a question yet. Go ahead.
Okay. Yeah. So it's a question about the CAM workbench. I've been trying to use FreeCAD for assemblies, and what I like to have as a tool is something that tells me that during this step of the assembly, that part is going to interfere with this part. It's on. And this is something that you actually have to solve for CAM. So is there any way to sort of get that kind of functionality into the assembly?
Well, the assembly workbench, the question has to do with the need for detecting, correct me if I paraphrase wrong, detecting collisions or interferences between parts within assemblies. Can you explain a little bit more how you see the overlap to the CAM?
So with the CAM tools, what you're doing is you're calculating the interference zone of a tool with an
With a part, okay. So how does a tool interfere with a part? For the 2.5D, the easier kinds of tool paths that we've generated prior, it's very simple offsetting. So there's no detection of whether or not the part is colliding with the model. It's simply offsetting the radius of a tool away from the lines in or out. The open cam lib, for the surfacing part, what it does is it takes the actual shape of a tool and pushes it against the shape of the model until there's an overlap between them, and that's the control point for that step in the tool path. So I don't see a direct way to generalize that from CAM into assemblies. Beyond that, the assembly part of FreeCAD is under heavy development right now. In fact, it's more a combination of add-on workbenches. And I'm not qualified to say, but yeah, that's about where that's at.
one in, one out.
Are you going to create a discussion forum software for support?
So the question is about alternative discussion forum for development of FreeCAD. Is that correct? So right now, everything is done through a PHPBB forum, which has an enormous amount of activity to the point that it's become almost unwieldy. It's difficult or impossible to keep up. The development is broken down into channels, so there's a dedicated path CAM channel where most of the discussion about the CAM stuff happens, and the same thing for Arch and the other workbenches. But a lot of the functionality or the development needs span multiple workbenches. So I would say, yeah, it's talked about, but I don't think we have a good answer for what a replacement would look like or how to migrate to it. If you've got ideas about how we can improve that or specific problems to address, you know.
So I see that there's some thermal modeling features in FreeCAD, and I'm interested in sort of energy efficiency in buildings. And are you using the thermal modeling in your architectural practice?
So the question is about energy efficiency modeling in FreeCAD. Basically, yeah, you can do it. Basically, what works at the moment is producing IFC models from FreeCAD and exporting to a software that accepts IFC formats such as OpenStudio, and then they're converted into an energy model. The problem is that for energy analysis software, you need a very, very specific simplified model, which is basically each room like this one is a box, and each face of the box has properties of how it lets heat go through. And it's a very simple model, very different than what you use to make the building, where you really want to model the walls and everything. So at the moment it's a bit tricky, and we cannot directly from FreeCAD output a model that's ready for energy analysis. But that's something I would like to have, to make. And we must think a little bit better how to do that, how to, let's say, model the traditional way with walls that have thickness and everything, and from that extract an analysis model. And it's doable. We will have a couple of ideas, but no real plan, practical plan on how to do that yet. But yeah, that's definitely on the list.
Is a package or library for Python to do as computation of fluid dynamics, but I'm very involved with this, generating solids or generating some features in other kinds of programming languages. So what kind of languages will you tell me that I am able to interact with?
So the question is, what programming languages does FreeCAD use? Basically, the core is all programmed in C++, and all the functionality on top of it is mostly Python. Basically, the C++ and Python interface are very similar. So we used to say basically you can work in FreeCAD either in Python or C++, and it's more a matter of your own choice than a technical matter. And because you can basically do the same in both languages. You can program a workbench fully in Python, fully in C++, or a mix of both. It depends mostly on your preferences. And most libraries that we use inside the project have both C++ and Python interface. So for example, the Qt for the interface, you can access it from both languages. And the same goes for every library that we use inside FreeCAD. So it's really convenient to use any of those two languages. And basically that are the two that are used in FreeCAD.
What are the most common outputs, the extensions that you are creating in solids, for example, STL or?
So the question is what geometry formats are the most commonly used in FreeCAD. I would say STEP is the most common one. STEP is a solid-based format. STEP format has like the solids are defined by their faces, and those faces can be NURBS that can be like defined by geometrical curves. So basically, you can just represent about anything with that, and it's a very solid file format that's there since ever, and all the engineering world still uses it. So I would say that it's the best format to work with in FreeCAD. STL is used a lot for 3D printing, but STL inside an STL file you don't only have points and triangles, so your curves will get faceted, turned into small facets, and so you can output things easily from FreeCAD to STL, but it's really hard to get back an STL into FreeCAD, and you won't have the curves anymore. So that's a good output format, and it's not a good input format. STEP is good for input and output, so it's basically what most people use.
But FreeCAD can import and export just about any solid model format,
like
BREP, IGES, DXF, etc.
Maybe one more question?
Just related to modeling part, I've noticed now integration of several finite element modeling tools in FreeCAD. Can you just outline the roadmap about integrating? At the moment, I find it very difficult to follow the evolution and get started with finite element modeling. So, is there any plan